Thank you for joining me on this learning journey. Today we're going to be going over problem 14 from the AMC 8 2019 test. Let's read through our problem. Isabella has 6 coupons that can be redeemed for free ice cream cones at Pete's Sweet Treats. In order to make the coupons last, she decides that she'll redeem one every 10 days until she has used them all. She knows that Pete's is closed on Sundays, but as she circles the 6 dates on her calendar, she realizes that no circled date falls on a Sunday. On what day of the week does Isabella redeem her first coupon? So I encourage you to go ahead, take a minute, try this problem on your own, and then come back and hit play on this video whenever you're ready. So I'm assuming you've given it a go. Let's start with our problem. So the way that I would solve this is by assigning a number to each day of the week as our starting number. And I would basically just do process of elimination here and kind of write out the different scenarios. So let's start with A for Monday. So if we start on a Monday, then our first date will be date number 1 and then 10 days later. So 10 to that will be 11, add 10 to that, that'll be 21, add 10 to that, that'll be 31, add 10 to that, that'll be 41, add 10 to that, that'll be 51. And then for B, which is Tuesday, we'll start with 2. Then add 10, add 10, add 10, add 10, add 10. Then here, we start with Wednesday. Then add another 10, 10, the same thing here. We just have to keep doing that for the different scenarios. And then in a minute, I'll show you how we know that which one of these is correct. So then we start with 4, 14, 24, 34, 44, 54. E would be 5, 15, 25, 35, 45, 55. So what we're going to do now is, they say that no circled date falls on a Sunday. No circled date falls on a Sunday. And we know that Sunday is our 0 here. And so in order for us to do this, we can either subtract, or we can divide these numbers by 7, and the remainder is what number will be here. Because if you think about it, days of the week, it's a loop. It constantly goes over and over again. So we would find the remainder of each of these when they're divided by 7, and if there is a 0, meaning that the number is divisible by 7. So if it has a remainder of 0, then that means it's divisible by 7. And so really all we have to do is look through this list of scenarios and see which answer choice does not have a multiple of 7 in it. Because if it has a multiple of 7 in it, then it'll have a remainder of 0, which is our Sunday number here. And how am I getting these numbers? Well, if we're looking at a calendar, if we are looking at a calendar with dates on it, just assigning a number value, just say that's a calendar, we can assign number values to it because with the days of the week, it goes on as a loop and it keeps going through like that. And we can add 10 days to each of that days of the week to kind of simulate what it would be like on that calendar. The only difference is we're doing it with numerical values rather than a visual calendar. And we're basically, if you think about this, these could even potentially almost be like dates on a calendar, except for, these flow into the next month as well. Anyway, we need to find the answer choice that does not have a multiple of 7. So here's where some more process of elimination comes in. Can it be A? Does A have a multiple of 7? Yes, it does. It has 21, so A has to be crossed out. B has a multiple of 7 as well, so we have to cross that out. C does not have a multiple of 7, so we can keep that as one of our potential answer choices. D has a multiple of 7, so we have to cross that off. E also has a multiple of 7, so we cross that off as well. So C has to be our answer. So we would circle C. So it starts on a Wednesday. So that's it for this learning. Thank you for joining me. I'll really appreciate it if you leave your comments, feedback, and further suggestions for additional learnings below. I'll see you in the next video.